Solutions to the Sec 1 WA1 for year 2022. In the first question, we want to find the HCF. The HCF consists of common factors, and first we look for the common 2, and since it's a factor, we're looking for the lower power, that is 2. And for 3, the lower power is 3. For 11, which is common, then the lower power is 11 squared. And the question did not tell us to leave the answer in index form, so we need to work out the total, which is 726. In the second part, we have to find the LCM of B and C. Now the LCM is a multiple, which means it's a bigger number than B and C, and it must have the factors belonging to both. Therefore, every number must be considered. So we start with 2 and then 3, and this time we pick the higher power because the higher power would contain the factor with the lower power. 5 squared. Every number must be considered. So the next one is 11 to the power of 4, and the last number is 13 squared. So now we have all the factors which belong to both numbers. That is the LCM. In the next part, we have to find the smallest integer such that CK is a multiple of A. So if CK is a multiple of A, then it should contain the factors belonging to A. So K is a number such that it will create factors of A. So in the first case, A has 2 to the power of 3. So C does not have 2 to the power of 3. So we need a 2 squared to create a 2 to the power of 3. And looking down the line, A also have 5 squared, and C doesn't have 5 squared, so we need to put down a factor of 5 squared. And the last factor is 11 to the power of 4, which we have. Therefore, the result is K must be 2 squared times 5 squared, which is 100. In part 4, we have to find the value of 3 times B. Now B is 3 to the power of 5 times 5 squared times 11 to the power of 4. So 3 times B will be 3 times 3 to the power of 5 times 5 squared times 11 to the power of 4. And that gives us 3 to the power of 6 times 5 squared times 11 to the power of 4. Use prime factors to explain why 3 times B is a perfect square. Now, if we look at the powers of all the prime factors of 3 times B, they are all even. So therefore, a square has even powers, right? Therefore, 3 times B is a perfect square. In the next sum, we have to find the cube root of this number. So therefore, the answer must be an integer. And A and B are prime numbers. Now when we multiply by a number, it increases the power. And in this case here, we want to increase the power to a multiple of 3 so that we can take the cube root. Therefore, on examination, we find that we need to multiply by 3 in order to make 3 to the power 5 into 3 to the power 6. And b, when we divide by b, it reduces the power. So the power that we want to reduce is 5 to the power 7. If we divide by 5, the 5 to the power 7 will become 5 to the power 6. So the result will be 3 to the power of 6 times 5 to the power of 6. And this is the number that you can take the cube root. The result will be an integer. Okay, 3 squared times 5 squared. Therefore, a must be 3 and b is 5. In the next sum, we have a group of children to be given candies, toys, and balloons, and we must give equally to each child the same number of candies, same number of toys, and same number of balloons. So since we divide out the candies and so on, we will get a smaller number, meaning that we are actually finding the HCF. Right, so the HCF, we find the common factor, the lower power, and the lower power here is 5, lower and common. Result is 20. So the greatest number of children present is 20. Now there are 200 balloons, so each child will get 200 divided by 20, which is 10 balloons. In number 4, we have to find a prime number. This is a prime number. Now a prime number has only 2 factors, therefore a must be 1. So that the prime number a times a plus 36 will become 1 times 37 is 37. Right? So a times a plus 36 is the number 37. In number 5, we have a sum that has intervals. Usually such a sum is an LCM sum, because what we need to do is to find the length of time that is common to both cameras. So to find the length of time is a bigger number, we have to find the LCM. So 15 is 3 times 5, and 24 is 2 cubed times 3, and the LCM is 2 cubes times 3 times 5, which gives us 120 seconds. And 120 seconds is actually 2 minutes. And we have to find in 1 hour the number of times they are scanned together. So therefore, number of times, 1 hour, by the way, is 60 minutes. Therefore, the number of times they scan together is 60 divided by 2 minutes. That is 30 times. The next question requires us to first find the irrational numbers. Now, irrational numbers must contain an irrational part. But for the this 559 pi over 250 pi, the pi is cancelled out, so there is no irrational part. So the first number is actually 18 divided by 2 is 9, so root 9 will give you a nice number 3. Therefore, the only irrational number is the root of a prime number, which is root 5. Because cube root of negative 8 is negative 2. And for prime numbers, now prime numbers is the first number, which gives us an answer of 3. The rest are not prime numbers. So we have root of 18 over 2. We cannot give the answer as 3 because the question gives us root of 18 over 2. We must use what is given in the question. Right now we need to arrange these numbers. To arrange these numbers, we need to convert them to decimals. Okay, the first number we know we have converted to 3. Alright, then the second number is 2.236. The third number is negative 2. And the fourth number is 559 divided by 250, which is also 2.236. Okay, so this one is 2.236. So root 5 would be 2.23606. Right? So we need to distinguish it. And the last number is 1.835 recurring. Right? So now we are ready to arrange the numbers. So the numbers, the largest number is root 18 over 2, followed by the next number is root 5. Descending order means the biggest must come first. And then we have 559 pi over 250 pi. And followed by 1.835 over 999. And the last number is the cube root of 8. Of negative 8. Because that will give us a negative answer. And negative numbers are the smallest. Now, we are to express 1 and 835 over 999. 999 will cause 835 to repeat. Therefore, 835 is the recurring part. So we have 1.835835, which we write as 1.835 with the dot on 8 and 5. Maximum is only 2 dots. So this will mean that 835 is repeating. In number 7, we need to manipulate with negative numbers, and we need to do the cube and also the square root first. Right, the cube and the square root must be done first. Right, so cube of negative 2 is negative 8, and since the answer is negative, we enclose in brackets. So now coming to the root of 49 is 7. Right, next we need to do the innermost brackets first. The innermost brackets is 3 minus 7, which is negative 4, which we enclose in brackets again, divided by 4. And here we have the result is negative 1. Enclose in brackets. Right now, we have negative times negative is positive, so plus two. Using the zero pair, we left with negative 6. For the last question, we have differences in temperature on a mountain, and we have to find what is the temperature at negative 6 degrees. We are given that the difference in temperature at the bottom is 18 degrees and at the top is negative 30 degrees, and this mountain is 2016 meters tall, and we have to find out what is the distance when it is at negative 6 degrees. To do that, we must first find the difference in temperature between the bottom and the top, and we always take the higher number minus the smaller number, and that gives us 48 degrees centigrade. Similarly, we find the difference at negative 6 degrees and the bottom. So we have again the higher number minus the smaller number, and that gives us 24 degrees centigrade. Now the difference of 48 degrees, this temperature actually represents the 2016 meters. Therefore, at the negative 6 degrees, which is 24 degrees difference, it represents 1008 meters, halfway. Right, so the temperature at negative 6 degrees, the distance at negative 6 degrees is 1008 meters from the bottom. This completes the discussion of the 2022 WA1. Thank you.